the screen. Thank you for letting me know to share the screen, for reminding me to share the screen. So the recording has started, so we can start. There are terms at which we'll have to go and check what they mean so that we just don't skip them. Now, with screen. Okay, the laws of science. So in the objective of this section is to learn the laws of science and the ambiguous case. So the laws of sign. Now they say the triangle, the trigonometric functions can also be used to solve oblique triangles. Is it oblique triangles? That is triangles with no right angle. No right angle, meaning that if your triangle is not a right angled triangle, then it's an oblique triangle. Now they say, for instance, if we are given two angles and the included side, then it is clear that one and only one triangle can be formed, right? Meaning that you can only form a unique triangle. So remember what we said. If you are saying included side, it means that the side has to be between these angles. So this is the included side. Are we all together, yes or no? Should I continue or what?
Yes.
Okay. They say similarly, if two sides and an included angle are known, then a unique triangle is determined. By unique triangle, they mean one triangle is determined, right? Because with some cases, you can even be able to determine two triangles from that, from the given information. And you'll see that later. Now they say, but if we know all three angles and no side, we cannot have uniquely determined the triangle because many triangles can have the same three angles. Is that clear or not?
Can you explain me?
They say that if you have all, if we know all three angles and no sides. So for example, here in the first case, we know angle, and side, right? That was the first case. Now in the second case, they say we have, yes?
Sorry to interject, man. An oblique triangle, is it the same as a scalene triangle?
It's any triangle that is not a right angle triangle. As
Oh,
long as it's
okay.
not like this. As long as you can't use the theorem of Pythagoras on it, it's an oblique triangle.
Oh, okay, man.
Yes, isosceles, equilateral, yeah, all those ones that don't have a right angle. Right angle. Yes, then you as long as you can't use Pythagoras theorem, then it's an oblique triangle. Now they're saying that, but if we know all three angles, let's say we know all these three angles. We know this angle, we know this angle, we know that angle. And we don't know this side or this side or that side or this side. We cannot uniquely determine the triangle, right? Meaning that you from if you know three angles, maybe you can even get 15 triangles from just knowing those three angles. You can form 15 or 3 or 2 triangles by just knowing the angles. So that's what they're saying. They say, but if we know all three angles and we don't know any side, we cannot uniquely determine a triangle because there are many triangles that can be formed from the same angles. Does it make sense or not?
Yes,
it makes
sense.
So they say in general, a triangle is determined by 3 of its 6 parts. Remember that when we look in the last session when we said determine triangular what, we were looking all the 6 parts, which is the find all 3 angles and find all 3 sides. So now they're saying here that you can determine all 3 angles, all 3 sides by only using what? 3 of its parts. Does it make sense?
Come again, ma'am.
So remember we said that in the last session, when you say determine the following triangle, it means that you had to go and solve all the sides and all the angles. And because the triangle has 3 sides and it has 3 angles, meaning that once you get all those parts, which are 6 parts, the 6 parts here, then you have calculated everything in that triangle, right? Now, they are saying that for you to determine the triangle, you just need 3 parts of that triangle to be able to determine that particular triangle. Does it make sense?
Yes, ma'am.
Oh,
So now
yes,
they
ma'am.
say, in general,
So,
a
ma'am,
triangle, yes?
does it mean, let's say you have an angle and 2 sides, you can be able to find the other missing information? That's what it says?
Yes, that's what they're saying. Or you have a side, or you have a side, angle side, or whatever. But now
Ma'am?
there are also more information there, because at some point you cannot uniquely determine. Remember, when they say that you are unique, they mean there is only one of you, right? So in some cases, where maybe in some we'll see those cases, is that you cannot only determine from the given information. Let's say you have 3 information, you cannot not only determine one triangle, a unique triangle, but 2 of them can come out. And some information you might not even have a triangle from that information. Are we together, or yes or no?
Ma'am?
Yes.
Ma'am, you mean when you have you mean when you have 3 angles and you don't have the side, you may any triangles with different sizes. Is that what you're meaning? No.
Please repeat. Sorry, I didn't hear you.
Yeah, I'm saying what you were trying to explain now was that you can have an angle with you can have a triangle with all the 3 angles inside, but you may make many triangles out of that.
Yes. Do you understand?
Ma'am?
As it said previously, that you might have, if you know all 3 angles, it means that you might have many triangles from that, because what's this? Many triangles from that, because many triangles, they might have the same angles actually. Do you understand? But then they might have different sides.
Okay. Mhm.
Yes. So now we need
Ma'am?
to yes.
Okay. So, all right. On this information presented here, like okay, so like it says that we can use either sides or and we can use sides to determine the angles, right? Depending on the triangle given here. Okay, so now can we use what's this? The sine rule to determine the angle there if we have a side that is parallel to this particular angle there.
Now, let's not go to the sine rule yet. Let's look at cases when to use the sine rule.
Okay, ma'am.
You understand? Remember, I
Yes,
said when you're
ma'am.
studying, you say how, why, and when. Now we are saying, when do you use the sine rule? How are we going to use this sine rule? And why are we using the sine rule? So we can't do the how to use it without knowing the when and why. Let's do the when and why. So now they say, in general, a triangle is determined by 3 of its part, angles and side. Do you understand? Meaning that, okay, sorry, angles and side. As long as at least one of these 3 parts is a side. Do you hear that?
Yes, ma'am.
Now here, what we said, this is not allowed, reason being we can generate many triangles from just knowing the angles. Therefore, that's why they say, as long as at least one of these, as long as at least one of these 3 parts is a side. So meaning all of them can be sides, 2 of them can be sides, or one of them can be sides, and the others can be angles. So now there are cases, there's A, there's B, there's C, and there's D. In A, you are given an angle, a side, and an angle, or a side angle, angle. And then in B, you're given a side angle. And then in C, you're given side angle, side. And then in D, you're given all three side. So there's case 1, where it says one side and two angles, which is A. This one here. Case 2, it says two sides and the angle opposite one of the sides. Angle opposite one of the sides. Do you see that? Now that's the second case. The third case says two sides and the included angle. Let's see, meaning that the angle has to be between the two sides. So this is a side, this is a side, and the included angle. Remember, when they say included, they mean it has to be between whatever they're saying the included is. So here they're saying two sides and an included angle, meaning that the angle will be between the two sides. Now, three sides. Now listen, when it says case 1 and case 2 are solved by using the law of sines. Case 3 and case 4 require the law of cosine. Do you remember case 1 and case 2, guys? Yes, no? Hello?
No.
No.
So do you see when to use this the law of sines? Guys?
Yes, ma'am. When
You
there is an
do-
included angle,
Mhm.
and when you have been given two sides and one angle. I don't know if I'm mistaken. Or is
So let's go
one
back.
side and two, yeah, one side and two
They say
angles.
case 1 and case 2 are solved by using the law of sines. Let's go to case 1. One side and two angles. Then if you see a triangle and you're given one side and two angles, then you use what? You use
The sine
the
rule.
law of sine or the sine rule. Thank you. And then two sides and an angle opposite one of these sides. Then you use the what? The sine rule. Let's look at that for 2 seconds because we have to use it. Are we all together? When do we use the law of sines, right? The
Yes,
sine
ma'am.
rule.
Yes,
Yes,
ma'am.
Yes,
Thank
ma'am.
Yes, ma'am.
Meaning that two sides and the included angle and three sides, it means that we are going to use the what? This is the cosine rule. This is the sine rule. Are we all together?
Yes, ma'am.
Yes, ma'am.
Thank you. Now, they say the law of sine rule says that in any triangle, the lengths of the side are proportional to the sides of the corresponding opposite side. So meaning that if we go back to how we used to define a triangle, right? We'll say this is A, this is B, and this is C. Opposite that side. So opposite to A is a small a, and opposite to C is a small c, and opposite to B is a small b, right? Then they say that then they say the law of sine says that in any triangle, the lengths of the sides are proportional to the sides of the corresponding opposite angle, which then gives us this law, the laws of sine or the sine rule. So they say in triangle ABC, we have that sine of A, meaning sine of this angle, divided by this side is the same as sine of this angle here, divided by the side, the same as the sine of this angle divided by that side. And we know that this can also be written as A over sine of A equals to B over sine of B equals to C over sine of C, small c here, right? We can also write the sine rule or the law of sines as follows. Are we all together? Yes or no?
correct.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now we say to state this law of formula more easily, we follow the convention of labeling the angles of a triangle is A, B, and C. And the lengths of the corresponding opposite as sides A, B, and C. Okay, we spoke about that. Yup. And then we go straight to a question. Okay, let's do the question then. We'll go straight to an example. Can we try this example, guys?
Yes, ma'am.
Yes, ma'am.
Let's try it. Let's analyze it first. I'll draw here because I think if I leave the slide, it might give the answer. Let's draw here. Let's draw. Tell me what's going on. They say a satellite orbits the Earth, passes directly overhead at the observation station in Phoenix and in Los Angeles at 30 miles apart. So in this case, we'll say what? 30 kilometers, ne? Kilometers apart. At an instant,
340 kilometers.
yes, 340 kilometers apart.
Meaning one
they
side is
say-
given.
Before that, at an instant, when the satellite is between these two stations, its angle of elevation is simultaneously observed to be 60 degrees at Phoenix and 75 degrees at Los Angeles. How far is the satellite from Los Angeles? Can we draw that? Guys? Hello?
Oh, ma'am, do we help you draw here right now?
Yes, you help me
Oh,
draw.
okay,
I don't know
okay.
what's going on. You need to, we
Okay.
need to discuss
Our,
in the
okay.
discussion class. Yes? Mhm.
Our first side would be the distance from Phoenix to Los Angeles. So that would be our distance. We could call
So what
that,
do I do? Do I
we
draw
could-
like
we
a
could- we could call point the Phoenix, we could call it point A, going to point B, which is Los Angeles.
so you say I should draw like a small Phoenix. What is it?
Sorry?
It's an
Okay.
observation station. So I draw like a small observation station. And then let's call it Phoenix here,
Okay.
right? And then they say and then there's Los Angeles.
Yes.
Let me, okay. Guys, when you analyze these things, let them be as real as possible to you. So this is an observation station. There are people in there observing. So this is what? LA.
That's, LA, yes.
Okay. So what are they saying?
The distance between them is 340 kilometers.
So from here to here
Yes.
is 340 kilometers.
Yes.
Yes.
And then at an instant, the satellite is between these two stations. So right in the middle, we're going to have our satellite.
Here in the middle.
Right in between Phoenix and LA. So no, at the top, at an angle of elevation. So
You're saying the satellite is here. It's up here.
yeah, we could say that. Yes, yes.
Okay. So here's the satellite. Okay, then?
Okay. Then its angle of elevation is simultaneously observed to be 60 at Phoenix. So we have an
What
angle.
is an angle of
60
elevation?
It is
What is an angle of elevation? Because we talked about this. What is an angle of elevation? What does it mean? Guys?
It means looking, if ever you are stationary either at Los Angeles, you are looking or looking up 75 kilometers elevating, meaning
Thank you.
You are
So this is
standing at the
you
bottom
here,
but elevating
inside.
up.
You are inside this building and you're looking up.
Up, yes.
That's elevation. Thank you very much. At angle of what?
75 degrees. Yes. Degrees.
75 degrees Celsius. And then when you're at
Okay.
Phoenix, you are looking, you're inside. Isn't that you're inside, you're observing? It's your job to observe. Don't look at TV and look upside down. You're looking up. That's your job. So that's why they say angle of elevation. So you're looking up there. So then this is what?
60 degrees.
60 degrees.
60 degrees. So now they say that how far is the satellite from Los Angeles? So what are they looking at?
They want us to find the distance between the satellite and Los Angeles.
Thank you. So let's call this P, the Phoenix. Let's call this L for Los Angeles. Let's call this S, the satellite. And we know that S, opposite S is a small s, right? Opposite P is a small p, and opposite L is a small l, right? Now, we are given what? We are given two angles and a side. Two angles and a side. And that's case one. Do you remember case one?
That's correct, yeah.
Yes, sine rule.
So that's we're going to use the what?
The sine
The
rule.
sine rule.
Sine rule.
Thank you. Now, what are we looking for? Right? Let's look at what are we looking for before we use the sine rule. Me, in my case, in metric, I didn't know where is the information. I didn't understand the sine rule. So I didn't know where is the information or where is not the information. So I'll just substitute everything and take the part that has information. Does it make sense? Yes or no?
Yes, ma'am.
Yes, no. Yes,
So,
yes, ma'am.
in this case, let's see. We have, what are we looking for first? We're looking for the distance, right? If
Correct.
this is how I would normally do it. If I'm looking for an angle, I'll put the signs on top like this. I'll write it like this if I'm looking for an angle. Are we together?
Yes, ma'am.
If I'm looking for a distance, I'll write it like this. Are we together?
Yes.
You can write it like this
Yes,
if you want and then do the calculations. But sometimes it helps to write it like this when you're finding the distance, because then you just multiply the other part. So let's look at this triangle. In this triangle, I've because we're looking for the distance, we'll write it like this. I'll write it like the sine of P, right, is equals to sine of small s over sine of capital S, and small l of sine of big L. Then I go and substitute. Because I'm looking for P, I'll keep this one, right? So this is P over what? Sine of P, right? And we know sine of P is what? Is 60 degrees, isn't it?
Yes,
Equals
ma'am.
to small s. We know small s, right? So small s is what?
Yes, ma'am.
340
It's 340
over
Sine
over
S.
sine
sine
big
S.
S. Now we go to small l and we say L over sine L, big L.
75 degrees.
Thank you, sine 75 degrees.
Sorry, ma'am.
Mm-hmm.
Is it not advisable to obtain the internal angle or the interior angle first?
Wait. The reason why I wrote it like this, I wrote it like this for someone who doesn't know if I have to obtain the angle first or I have to obtain what first. Does it make sense?
Oh, okay. Yeah.
That's why I wrote it like that.
Yes.
Okay, so let me do this and discharge. before I discharge. Okay. Let me say keep. I don't want us to see our solutions before we understand the work. Okay, let me open it up first. Screenshot. I want this part. Because I know it also used to confuse me. So that's why I'm saying that I don't want us to first go and find, because what's this? Escape. Let's go to Word. Okay. Now, so you go and look at this. You're like, okay, fine. I wrote this part over here. I have sine of, sorry. I have P over sine of P is equals to S, which is 340 kilometers over sine of B. Then I have L over sine of 75 degrees. Do we agree we have to keep this one here? Yes or no?
Yes.
Ma'am.
Yes, ma'am.
Because
Yes.
it's what we are looking for. Sorry, here we were supposed to say sine of 60 degrees. It's because it's what we are looking for. Now, between this one here and this one, which one do we keep? It is based on if you can be able to find the information that is missing. Then you decide which one to keep between this one and this one. Are we all together?
That's correct.
Thank you.
Yes, ma'am.
So meaning that if you are confused, write all of them and then go back and say, okay, let's see. Can I find L? Is it possible for me to find L? Guys, is it
Yes,
possible
it is.
for me? With what?
It's possible, but now we're looking for P, I think.
Yeah,
No,
but
we
now,
can't. There's a value that we have to find first before we can be able to find the value of L.
do you see that? So meaning that it's not easy for us to find L. And because it's an oblique triangle, it's not a right angle triangle, meaning that we cannot use Pythagoras theorem. You know, with Pythagoras theorem, it's easy when you have two sides and then you can, you know, but with this one, it's an oblique triangle. So it's not easy to find L. Are we all together?
Yes, ma'am.
But can you find sine of S by looking at your triangle? Look at your triangle. Let's go back. Look at your triangle, and sine of S is this angle here. Can you be
Yes.
able to find that?
Yes,
Yes.
ma'am.
Yes.
Yes,
By
easy.
using
Yes, ma'am.
75.
180.
So meaning that if it was confusing for you to decide which one to cancel, then you could do that and remain with this one there. But if it was not confusing, you saw it, you can just go directly and write sine of P over sine 60 and equals to 350. I mean, what's this? 340 divided by sine of S. Now, what do we know? How can we find this angle here, angle S, right? We know that the sum of angles in a triangle is equals to 180. So it's the sum of angles in a triangle is equal to 180 degrees. So meaning that we can add angle P plus this angle plus that angle, angle L plus angle S is equals to 180 degrees. Now, because we know, lucky for us, lucky for us, I don't know why the whole thing is moving now. Let me go back, up, back, and then go back, go back, go back, go back. Yes. So let me move it with my finger. Lucky for us, so angle P plus angle L plus angle S is equals to 180 degrees. The reasoning is because sum of angles in a triangle is equals to 180 degrees. Whether it's a right angle triangle, whether it's an oblique triangle, as long as it's a triangle, the sum of its angle is equals to 180 degrees. So then we know we have a 60 here. So this is 60 degrees plus, do I have an L? Yes.
75.
Thank you. But I'm looking for S, so I don't have it. Degrees. So then this is equals to 180 degrees minus what?
Minus 60 minus 75.
Which is equals to?
45.
45.
Which is equals to 45 degrees. Meaning that this here over here is equals to 45 degrees. Meaning that we need to take this one and bring it here and now do what? And now solve. Let's do that, but let's choose a different color. So we know sine. We know that the small p is equals to sine of 60 degrees equals to 340 degrees, 40 kilometers over sine of 45 degrees, which is equals to, so this one is equals to, p is equals to 340 degrees sine of 60 degrees over sine of 45 degrees. Now in the exam, because I know you know sine of 60 degrees. What is sine of 60 degrees by heart? Come on, guys.
Pi over 3.
Square root of 3 over 2.
5 over 3.
Pi over 3.
Oh, 5 over
It's what?
Pi over 3.
Pi over 3.
Square root of 3.
So you're saying this is equals to 3
Square root of 3 over 2.
Why is it pi over 3? Thank you.
Do we need the coordinates?
Yes, remember sine of 60 degrees is the same as sine of pi over 3. What is sine of pi over 3 then? The answer?
Is root 3 over 2.
3 over 2.
3 over 2. Divided, what is sine of 45? This one is easy, guys. You need to always remember it.
2 over 2.
Yeah.
Thank you. So do you see how I can even put it in the exam? We don't need calculators, isn't it? So this is the same as 340 root 3 over 2 divided by root, what's this? Divided by root 2 over 2. So this one we can write it as 340 root 3 over 2 times 2 over root 3. Root 2. So then this is equals to 2 cancels that. So then this is 340 root 3 over root 2. Are we all together?
Yes, ma'am.
So in the exam, I can leave it like that because I know you will be able to find it using a calculator. So you can use a calculator just to finalize the answer. Guys, for now you can use it.
416,41.
So it's 416,41.
Yes.
Yes, ma'am.
Kilometers.
Okay. Just give me a sec. Now, I might also write it like this. Sorry, wait a minute. There's something. I must also write it like this. In the exam. Remember, exam is multiple choice, so I might write it like this. So 340 root 3 over 2 is also what? Check. Did you check, guys?
It is still 416,41, ma'am.
You see that it's still 416. Why? Because I applied the property that the square root of a over the square root of b is the same as the square root of a over b. So in the exam, I might leave it like this as your answer. Give you, say, a satellite, what, not, and then give you the answer like this. Because I know some of you will, maybe, I don't know, will think maybe to use a calculator. You can't use a calculator in such cases. Are we together? But if it's not special angles, let's say this was sine of 32 degrees, and this was sine of 2 degrees, for example, not 2, let's say 20 degrees. I'll leave it like this in the exam as one of the answers. Are we all together? Yes or no?
Yes, ma'am.
Yes, ma'am.
Thank you.
Yes, ma'am.
Yes, ma'am.
So let's see. Okay, that's what we had. Well done to us. Well done to us. Okay, so they used how they use the formula like this, ne? Which is still fine. They didn't use B over sine B, C over sine C. Okay, all right. 416. So the distance of the satellite from Los Angeles is approximately 416. Are we happy?
100%.
Thank
Yeah.
you.
Yes, ma'am.
I'm giving you 2 minutes to go and check what what's this ambiguous case mean. The word ambiguous. I just need 2 seconds. Then I'm coming back. The word ambiguous. I come back. What does the word ambiguous mean?
It means unclear or confusing.
So
Not
what is
having
yes?
not having one obvious meaning.
Doesn't make sense. So meaning in this case we might
Open to
consider
more than
we might
one
look at
interpretation.
yes. So in this case it means it's that case, the second case. Remember the second case where they say we might have okay, what did I do? Hey, I need to close my screen. My video. What if hey you
We
don't want to
almost
see
saw you, ma'am.
We
We
saw it
almost
all.
saw you.
yeah, you might see one day I might be teaching naked. You never know. Hey, I need to cover it up. Okay, so as you say, it might not be a clear case as we had here. So in the Bible, what's going on? The video keeps wanting to. Hey. Okay, let me remove this part. So the ambiguous case. Let's go back. With back. Okay, what's doing this? Before we go to the ambiguous case, here it was clear we had the side, and we were able to find the length of whatever. It was a clear case, basically. Now, when it comes here, the ambiguous case, so they're saying in example 1, a unique triangle was determined by the information given, meaning that we had the information and then we were able to find the other information. And that was only one triangle. Do you see that? Now, they say this is always true for case 1. Meaning for case 1, we'll always have one unique triangle. But for case 2, we have a side, and an angle. There may be 2 triangles, 1 triangle, or no triangle with a given property. So that's why they're saying it's ambiguous. It's an ambiguous case because you don't know whether you're going to get 1 triangle or 2 triangles or 3 or even no triangles given the properties that you're given. Does it make sense now?
Yes, ma'am.
Yes, ma'am.
So for this reason, case 2 is sometimes called the ambiguous case. As you say, it's a confusing case. It's a case that is not straightforward. It's a case that is not clear. So to see why this is so, we show in figure 6 the possibilities when an angle A and a side A and B are given. For example, in part 1, why am I saying for example? In part 1, no solution is possible. Why? Because look at now, guys, sorry, I'm getting too excited. I'm explaining angles and I'm reading at the same time. This thing of multitasking. Okay, so let's try it. To see why this is so, we show that figure 6, the possibilities when angle A and side AB are given, in part A, no solution is possible, since A is too short to complete the triangle. In part B, the solution is a right triangle, right? In part C, in part C, 2 solutions are possible. And in part D, there is a unique triangle with the given properties. Are we all together? Yes or no? So the reason why they're saying the ambiguous case, it means you can have this case where one of the side is what? Is very short and not forming a triangle. Do you see that? Then you don't have any solution. Or you can have a solution like B here, where it forms a right angle triangle, right? Or you can have a solution like C, where you are given information, and then when you are supposed to calculate the information, now you have 2 triangles. You have this small triangle inside here, and then you have this outer triangle there. Or you can have case like what? Case like D, where you only have one complete unique, they call it unique triangle. The ambiguous case. Are we together?
Yes, ma'am.
Thank you. Now they say we illustrate.
Yeah, man.
You say?
Saying so a right angle triangle also falls under ambiguous case.
Yes, yes, it falls under the ambiguous case, right? But they're saying that if you are given, remember, they're saying that if you are given 2 sides and an angle, it's an ambiguous case, because what happened is if maybe you go and draw those sides, right? Or you calculate those sides, you might find yourself that one of the sides is too short to even form a triangle. Do you see that? Or if you go and let's say draw the sides, one side, when you draw it, it can even form a right angle triangle, right? Or if you then go and draw with the given information, they might give you, they say you have a side, and an angle, and then you draw it and you see, man, or you calculate or you do something and you see, man, one of the sides is short, so meaning it can't form a triangle, so there's no solution. That's one case of an ambiguous case. Let's call it one type of an ambiguous case. Another case, they can give you a side, and an angle. You do some calculations or you do some drawings or whatsoever, and you're like, hi man, this one forms a right angle triangle. Do you see that? So if it forms a right angle triangle, then it's fine. Or you can give again 2 sides and an angle, and those 2 sides, you go do some calculations, and you find yourself now having 2 triangles instead of 1, which is the case in C.
Actually, there are 3, ma'am.
You're saying what?
Actually, there are 3 in C. 3 triangles.
How?
Is the small one, which is ABC. And there's another one which is CBB. And then there is ABC, the outside one.
That's an angle.
Okay.
Here we're talking about triangles, the possibility
Oh.
of giving triangles, yes.
Oh,
So
okay.
now, yes. So now they're saying that, okay, they can give you again side, and an angle. You do some calculations or you do whatever, and you're like, I'm getting 2 triangles now. That is your case C. Case D, you are still given side, and an angle. You do some calculation, you draw that triangle, and you found that I only get 1 triangle. So meaning that if they give you a side and an angle, you can get one of these 4 cases. So then it's called the ambiguous case. Side, angle, it's the ambiguous case. Are we all together?
Yes, ma'am.
Yes, ma'am.
So let's see. Now they say we illustrate the possibilities of case 2 in the following example. Let's look at this one. They say the triangle ABC, where A is 45 and, solve triangle ABC, where A is 45. Angle A is 45, A is 7√2, and B is equals to 7. So when they say solve a triangle, what do they mean? Remind me, please.
You find all the sides and angles.
Thank you. So it means you have to go and find all the sides and what?
And the angles.
And the angles. So let's see. Can we do that? Okay. Let's write it. We have this. Okay, let me not write too much so that we can. So we have this one where we have A, B, and C, right? And we know this will be small c, small a, small b, right? And we know small a is equals to 7√2. I'll allow you to use a calculator here. And then we have 7. And then angle A, it's this one, is equals to 45 degrees, right? So now, where can we start? Where can we start? Let's go there.
Ma'am, can't you find the angles inside for C and B?
Yes, that's what we want. We want angle C and B. We also want side C because we only have 3 parts and we want the remaining 3 parts when they say solve for a triangle.
So you're going to just say 180 minus 45 and then divide by 2 to get both of them.
But you can't do that.
Sorry, ma'am.
Yes.
Can't we use, remember A, we've got the angle and then we've got the length.
Okay, wait. You can't do that because sometimes, you see me, I draw a triangle like this. This triangle can even be like this. Like this, something like this. And say A, B, and C. Something like that. Like a funny triangle, basically, because it's an oblique triangle.
Sorry, before you continue. So you mean that this triangle is not equal, so I cannot do that. It doesn't have equal sides, so I cannot calculate it that way. Oh.
Yes, because and they didn't even say to you angle B are equal. If they were equal, you say, okay, fine, just divide by 2, but you can't do that. You can't. Okay, now someone was talking. Yes.
Yes, I was saying, on this case, we have angle A and we've got side A.
First, which rule are we using? I know we learned one rule, but which rule are we using and why? Let's start there.
Ma'am?
On this one, yeah. On this one, I think I was going to use the sine rule.
Why?
Law of sine.
Rule of sine
Because
it has 2 sides and
you're given 2 sides
one
and
angle
an angle.
And one
opposite to the
angle,
side.
yes.
Thank you. So we have side, and an angle. Good.
Yes.
So meaning that we can use sine of A over A equals to sine of B over B equals to sine C over C. Remember I said you can also write this as A over sine of A equals to B over sine of B equals to C over sine of C, whichever you're comfortable with. Okay, then what?
So sine A is given.
Okay, sine A is given, so sine of 45 degrees over
7 square root 2.
Okay, then
which is equal to 7 over sine B. So we can find the angle B.
Wait, you're saying 7. Which one are you using? Are you here or are you here? Are you using this one or are you using this one? Because now you are confusing the two. You said sine over 45, sine 45 over 7 root 2, isn't it? So equals to what?
Sine B over
sine
7.
over, yeah, sine B over 7.
Over 7. So from here, you can see you cannot use it. It's easy not to use a calculator. Okay, because you know A is equals to B. You can also write B as equals to A. Because we are looking for this, let's take it to the other side. So this will be sine of B over 7 is equals to sine of 45 degrees over 7 root 2. Are we all together there?
That's correct.
Then we know sine of B is equals to 7 sine of 45 degrees over 7 root 2. That cancels. So sine of B is equals to, we know what is sine of 45? That's root 2 over 2, isn't it?
That's correct.
2 over 2.
Divided by root 2. So we know that this will just be equals to what?
1
What's the
over
answer?
2.
Let me close.
1 over 2.
It's 1 over 2.
1 over 2.
1 over 2.
1 over 2.
So that's 1 over 2. Do you see that you don't have to use a calculator in some questions?
Yes.
So then sine of B is equals to 1 over 2. So how do we find B? We learned that last week. How do we find B?
The inverse of
The
1 over 2.
inverse of 1 over 2.
So
It will
this,
give you the
then
angle.
this is B is equals to arc sine of 1 over 2. And what is arc sine 1 over 2 without using a calculator?
That should be,
Without using a calculator.
Isn't it 60?
Let's see. You're saying it's 60. Okay. Guys, you know, when you come to trigonometry, write your special triangles down. So you're saying 60, 30, 1. So this is 2 and this is root 3. But sine is opposite of hypotenuse. So it's not sine. What is it? It's not 60.
it's
What
30.
is it?
It's
30.
It's 30 degrees, ma'am.
Yes.
It's 30, right? Because sine is opposite of hypotenuse.
Over
So it's 30.
hypotenuse. Yeah.
So it's 30 degrees. Okay. I just want to correct something. What about, why not 150 degrees? Guys, what is sine 150? It's not a special angle. You can use the calculator. What is sine 150?
It's 1 over 2.
1 over 2.
It's 1 over 2. Do you see that? Now, what was the restriction of an arc sine last week?
It was between minus
Minus
pi
one
over
over
2
2
and pi over
and pi
2.
over 2.
Pi over
Okay,
2.
which is in degrees, it's minus what?
Minus 90 and 90.
Minus 90 and 90.
Well done, right? But now we are focusing on triangles. So you don't focus on that restriction when it comes to focusing on the triangles. Does it make sense?
Okay.
I don't want you to confuse the two because we are focusing on a triangle. You're saying what? Okay, let me repeat. Because we are focusing on triangles, ne? Because this answer is correct. If we're looking at the inverses of sine, for example, if I was saying find arcsine of maybe, let's say 1/2. If I was saying find arcsine of 1/2, then your answer will be 30 degrees because I know the restriction is between 90 degrees and what? And positive 90 degrees. Are we together?
Yes, ma'am.
Now,
Yes, ma'am.
because it's triangles, ne? Because it's triangles, arcsine won't have restriction in this case. It's because there's an angle that can be 105 degrees. Are we all together, guys?
Yes.
Thank you. So meaning that here you will say, okay, fine, you can go and do your restriction, that restriction, and say, okay, there's 30 degrees. Do you see that? For now, let's focus on 30 degrees. For now, let's focus on 30 degrees. So meaning that we're saying sine B is 30 degrees, right?
Yes.
But there's a rule. What does complementary mean, if someone remembers?
They add up to.
It's complementing other angles, no?
They add up to what?
They add up to
90.
360.
Someone said 90. Well done. It's actually 90 degrees. And,
Okay.
and then supplementary, they add up to?
180 degrees.
180.
180 degrees.
Thank you. So now you need to go and find an angle. Okay, let me fix this. We said that when we are using arcsine, our angle that we get has to be between what? Negative 90 and 90 degrees. That's what we said, isn't it, from last week?
Correct.
Yes, ma'am.
That's what we got now, which is 30 degrees. Therefore, the answer is correct in that interval. Now, because we are looking at triangles, we also need to go and check an angle that is supplementary to this triangle. Are we together?
Yes.
Guys? So what is an angle that is supplementary to this triangle? Sorry, angle supplementary to this angle that we got here.
That's 60, man.
150.
Thank
It's
you.
150
150.
It's 150, ma'am.
Thank you. 150 degrees.
Ma'am,
Because we said supplementary, yes?
Is it supplementary or complementary? Because you said complementary.
Okay. I was just wanted to check if you remember the definition of complementary and supplementary. Now it will be supplementary because the sum of angles in a triangle is equals to 180.
Right.
So it means we'll be, yes. So it means we'll be dealing with supplementary. I was just checking if you remember the definition of complementary. So now, so what happened is after finding your answer for arcsine, that you go and check the supplementary of that angle. It means that you go and check an angle such that when you add with whatever you have found is 150. Are we together now? Yes or no?
Yes, ma'am.
Guys? So meaning
Ma'am,
that...
can you repeat it
Can I
again?
ask?
Yes. You can ask, then I repeat.
Okay, ma'am, sorry. When dealing with what's this ambiguous cases, is it always a case whereby we have to find an angle and after that find maybe 2 or 3 angles that go with that angle?
Yes. When it comes to ambiguous cases, when they say solve a triangle, they want you to find an angle, a side, a triangle. You just go moving around, finding sides and angle until you get all 6 parts. All 3 angles and all 3 sides.
How do I know how many sides am I supposed to find in that particular triangle? Or
You look at the information. You are given an angle A, so we went and substituted A. You are given a side A, we went substituted side A. We are given side B, we went substituted side B. It means we don't know side C, we don't know angle B, and we don't know angle C. Do you see that? So we then have to go and look for those ones.
So, ma'am, the 150 was also for, is it for C, the angle C?
Okay, the 150, we're still looking at B. You understand? 150, we're still looking at B because they didn't draw triangle ABC for us. So we can't assume that B is equals to 30 degrees. B can be an obtuse angle and not an acute angle. We don't know. Does it make sense?
Yes, ma'am.
Yes. So what we do is you go and, okay, you understand up to where we found 30 degrees, isn't it?
Yes, ma'am.
Yes.
Yes,
we
ma'am.
understand that part.
So since you understand that part, you can't leave it like that because you don't know. They didn't draw the triangle. They just say solve the triangle ABC. So meaning that B can be a small, remember what an acute angle is, an angle less than 90 degrees, and obtuse angle is an angle over 90 degrees. So you don't know if B is like this or B is like this. So you don't know. So meaning that it's a 30 degrees or the complementary of 30 degrees. I mean supplementary, sorry, supplementary of that degrees. Does it make sense? So
Yes,
now,
ma'am.
how do you decide which one is right? So B can be equals to 150 degrees, or B can be what? 30 degrees. But for you to decide, you go and take the given angle. What angle are you given?
45.
45. And then you say 45 degrees plus 30 degrees gives you what?
45.
75.
It gives you 75 degrees.
75.
That is still less than 180 degrees. So 30 degrees can be correct. Are we together? Then you go and take 180 and say 180 degrees. I mean, sorry, 150. So you say 45 degrees. You say? So you're saying 45 degrees plus 150 degrees.
Why is like 45 degrees plus 30?
It's because it's the angle I'm given. 45 is the angle I'm given, right? Now, 30 degrees is the angle I found. But there's a rule that says once you find the angle, you need to do what? You need to go and find the complement as well. Because the answer can be that angle or the answer can be the complement. Or
So,
the answer can be both.
The complement, is it always like, okay, I know this one was oxine, so the complement will always be the opposite.
Supplement.
Sorry.
Yes. So the supplement, continue.
So the supplement it must always be the opposite of arc. Like in this case, you use sine. That's how you found it was 180. No, 180. No, okay, yeah. Not 180, 150.
So the thing is, yes, because if I went and say sine 150, I also get half. Do you know that? If I say sine 390, I'll still get half. Do you see that? If I say sine, let's see. If I say sine 750, I still get half. Now, which one is which? Obviously, it can't be 750 because what? It can't be over 750. It can't be over 360, meaning that I'll focus on angles that are less than 180 because I know angles that if you add all the angles in a triangle, they give you 180. And in this case, sine 30 gives us what? 1 over 2. Sine 150 gives us 1 over 2. So meaning I need to focus on both those triangles. Now, how do I decide? Meaning that because arc sine of half can either be 150 or can either be 130. There are two answers, isn't it? Same thing. If you
Yes.
say so the arcsine of can also be 150. Both of these are less than 180, meaning that B can either be this one or B can be that one. Or B can be both of them even. Or B can be none of them. So let's see. Now, how do you decide which one is which? Whether B is both of them or B is none of them. You go and take the given angle. In this case, you are given 45 degrees. You then say, okay, fine. 45 degrees minus 30 degrees. You see it's 75, isn't it? So meaning that B can be 75. Voila. Are we okay there?
Yes, ma'am.
Now you
Yes,
go and
ma'am.
get take the second one, which is a complement of what you had. So you say 45 degrees plus 150, what do you get?
195.
195.
195.
195. So what can we say about 150?
150 does not fall under that triangle.
Why?
Because it's bigger
Because
than
it's
180.
greater than 180.
Thank you. So meaning that our angle B is what? 30 degrees.
30 degrees.
Thank you. So meaning that our angle B is 30 degrees. Now someone might ask, why is it necessary? You will see why it's necessary. You were supposed to do the blue part. You will see why it's necessary. So meaning that our angle B is what? It's 30 degrees. So we go here, right here, 30 degrees. So how can we find C, guys? Someone help me. How can we find C?
45 plus 30 from...
Thank you. So it's 45 degrees plus 30. Okay, let's write it nicely. So we know angle A plus angle B plus angle C is equals to 180 degrees. Why? Sum
of the angles of a
angles
triangle.
in triangle. Thank you. Now we know A is 45 degrees plus B is 30 degrees plus C, we don't know, 180 degrees. This implies that C is equals to 180 degrees minus 30 degrees minus 45 degrees. What is the answer? C will be
105.
105. Thank you. So now that we have found B, we have found C. What is missing?
The big C.
The small c.
The small c.
Thank you. The small c. I'm the one who made a mistake here. This is a big C. This is an angle. Okay. Now the small c. Can someone help me? How would I find the small c? So because I'm looking for the small c, obviously I'll have C over sine of C. Or because we started with sine on top, let's be consistent. So it's sine of C over C. So which other one can I use?
I'll use a...
Ma'am, can I ask before you continue? Sorry. Is it advisable for me to use the angles that I've gotten? Or can I just use the ones that were given in order to find the C? Because I might not know whether I'm right or wrong or what.
So that's a good question. In mathematics, right? It is advisable to find what you are given, right? Because in most cases, what you are given will, let's say, for example, what you calculated was wrong. Then it saves you to get a correct answer from what you are given. But if, for example, if what you are given is not enough to find what you are looking for, you can always go and check what you're looking for, what you got to solve what you are given. That's why there's also something called continuous marking. Does it make sense? Where, for example, I see all your steps are correct, ne? I will mark here. I'll mark here and I see the steps is correct. And you got 106 here, ne? Then I will mark you wrong here. Because I know you have to use 106 in the next one. If you use it correct, it means the next one I'll correct it, all of it. Do you see that? Does it make sense?
Yes, ma'am. Thank you.
Yes. So I'm saying that it's always advisable to use what you are given. But if it is push comes to shove that you have to use what you have calculated. Let's say instead of 105, you got 106. Because I'm seeing that all your steps are correct. I can mark all of them and give you wrong on the answer. But because you are going to use 106 in the following, it means that the following in mind, I'll know you have used 106, 106. Then I'll mark all of it correctly if the step is correct because you made a mistake or something. So that's continuous marking. So I won't mark you wrong if the whole step is correct and you use 106 instead of 105. But it's advisable to always use what you are given. But if not, then you can always do that. Okay, so sine C over C is equals to what, guys?
Sine 45 over 7, the square root of 2.
Sine 45 degrees over 7, the square root of 2. I know C is what? 105, isn't it?
Yes.
So that is sine. You can use your calculator here because 105 is not a, what do you call it? 105 is not a special angle. So meaning that, let's calculate here.
Ma'am, I think my network is down. Where are you now?
I'm on C is equals to.
Okay.
Sine of 105 degrees over. But can you hear me? Guys, what are you getting?
Yes, ma'am, but it's in slow motion.
13,52.
13,52.
13,52. I think maybe your network is down. I'm not sure. Am I clear on my side?
Yes, we can hear you.
Yes, ma'am. Yes, ma'am.
Okay.
Yeah.
So now we have found A, we have found B, we have found C, and then we have found angle A, we have found angle B, and we have found angle C. It means we have solved the triangle ABC. Is that right?
Yes, ma'am.
Guys? Good.
Yes,
So let's
ma'am.
see
Yes.
the start. Let's see the answers now. Okay, that's the triangle we had. And then we did this. We're trying to find angle B. And we found that angle B is equals to 1/2. That's what we got, isn't it?
Yes, ma'am.
Yes, ma'am.
Yes.
Thank you. So now they say, which angle B have sine is equals to 1/2? That's what we said. By proceeding section, meaning that from what we have learned, we know that there are two such angles smaller than 180, which is 30 and 150. Now they say, which of these angles is compatible with what we know about the triangle ABC? So that's what we did. We said, okay, let's look at B. We said B is 45 or 180. We know 45 plus 150. We saw that it's greater than 180. We were like, nah, that's not the right one. And then we went to C and we said, what's this? Well, we went to C and then we checked that B is actually the correct angle. And then we went and calculated C. We found that it's 105. And then we went and calculated we went and calculated C, we got that it is, small c, we got that it's 13.5. Are we all together?
Yes,
Yes, ma'am.
Yes, ma'am.
Thank you.
Yes, ma'am.
In example 3, there are two possibilities for angle B, and one of these was not compatible with the rest of the information. Now, you see it's in red, you need to know it. They say that if sine A is less than 1. Are we all together?
Yes, ma'am.
In this case, our sine B was equals to half. And we know half is less than 1. Then we got that we must check the angle and its supplementary as possibilities. We got 30 degrees, its supplementary was 150 degrees. Because any angle smaller than 180 can be in the triangle. Does it make sense? We explained that part, isn't it? Guys? Yes or no? To decide whether,
yes, ma'am.
so now they say to decide whether either possibility works, we check to see whether the resulting sum of the angle exceeds 180. That's what we did. Now they say it can happen, as in figure 6C, this one. Now they're saying we are here now. There you see we only found one triangle, isn't it? Guys? In that case, it was one triangle. So meaning it was
Yes,
case
ma'am.
D. It was this case here. This case here. Now they are saying, okay, let's go to this case now. So they are saying that, let's see. They're saying that it can happen, as in figure 6B, that both possibilities are compatible with the given information, meaning that it can happen that you see there 150 and 30. 150 was not compatible, isn't it? 150 was not an angle, one of the angles. So meaning that it can happen that the supplementary is also in the angle. So meaning that we need to do something. What happens then? It means you end up with two triangles like this. So you end up with A, B, C, and the big A, B, B, like that. So now here's a question. Let's solve this quickly and I'm allowing you to use this one I'm allowing you to use a calculator on this one because you can see it's not special angles. So they're saying we have this. So we have A, B, and C. Angle A, we are given. It's 43.1 degrees. We don't know C. We know small a. We know small b. Small a is 186.2. Small b is equals to 248.6. So let's solve the problem, guys. Let's start. Let's start. Hello?
Ma'am?
They say solve the triangle.
Can I try, ma'am?
Yes, please.
Okay, the way I'm looking at the information, we should determine angle B.
Hello?
Yes.
Okay, so now we're just gonna say A over sine A equals to B over sine B.
Okay.
All right, so like we're given an information, so like small letter A, it's equals to 186.2 over sine of A, which is 43.1 equals to 248.6 over sine B. Okay, so now we're gonna do a cross multiplication from here. We're just gonna say 248.6 multiplied by sine of 43.1.
I'm sorry. Yes.
Over sine B.
Yes, and then on the other side.
Oh, on the other side, it is still 186.2. So therefore, we're gonna cross multiply here. Sine B will cancel. Well, yeah, we're gonna multiply 186.2 with sine B. Meaning we're gonna cancel sine B on the other side.
Okay.
And then we're gonna divide 186.2 on both sides.
Okay.
Then we're gonna
give me the answer then.
Sorry, ma'am. The answer will be B is equals to sine inverse of 248.6 sine 43 comma 1 over 186.
Wait. What is 246.6 sine 45 comma divided by, what is the answer?
Okay, let me check it out. 186.
65.982.
Before that, what is the answer?
It's not
the answer
0.91.
0.90491574997.
0.9. Is it 0.9?
Yes, ma'am.
91225.
True.
25. Let's make it 1, 2, 3, 4, 5 decimal places, okay? And then
therefore B is equals to sine inverse of 0.91225.
So B is equals to inverse of 0.91225. Yes. So B is equals to what?
Which will give us 64.81 degrees.
No, 65.
65.
Not 64.
Wait, ma'am.
Yes.
On the decimals here, that is not the answer that I got. I got 0.90.
Okay, let me see
Mama,
from my
I
side.
made a mistake.
No, his calculator is in radians.
No, it's in degrees. It's in a degrees mode.
So you made a mistake somewhere.
Yeah, maybe on the rounding off.
Wait, can I ask what made you guys decide to use A over sine A instead of the sine A over A?
I also wanted to use that one because it is easier because I'm finding an angle. But if they used it, if you want to use that one, it's still fine because we're still going to get the same answer.
Oh, okay.
Yeah. Because for me, it was going to be short. So I'm like, this one. But then if you are comfortable with A over sine A and you're comfortable with sine A over A, it's up to you.
I will never use it.
Oh, sorry, ma'am. No. It's correct. It's correct. This answer
yes,
is
so
correct.
that's I'm also getting 0.9. Okay, let's put it into 1, 2, 3, 4, 5 decimal places. Yes. So you get what?
65.82 degrees.
Okay, let's see how many degrees. I need to go back. Let me see. I don't want to show you the answers though. Okay, let's say 65.82. I don't know how many decimals. Oh, no. It's directing us. Look at the angle on top. How many decimals is it? Let's stick with the angle on top. Well, how many decimal is it?
One.
One.
One decimal.
So meaning there will be 60?
65.8.
55 degrees, 0.8. And then, what do I do next?
You add the interior angles.
What do I do next?
The sum of the interior angles is equal to 180.
That's a step further. What do I do next?
Okay, the inverse. The
Why?
inverse of the sine. Yeah.
Wait, someone said 180 minus 65.8. Why?
Because they are supplementary. You have to find the supplementary.
So let's call this angle B1 and then angle B2. Remember we said that we go and check the answer we got. We check if what's this? Sorry. We can't call them B1, B2 yet. We have to call it, B can be either 65 degrees, 0.8 degrees, or B can be what?
114 over 2, 0.2. 114.2 degrees.
114.2 degrees. So B can be one of this one because these two are supplementary. So how do I check if B is one of which one?
You add them together to see if it's less than 180. Since a triangle, it must be the sum of 180.
Now, okay. Adding them together will definitely give us 180. But we want to check if B is this one or B is that one.
Ma'am, B is none because both of them, when you punch them in the calculator, they are greater than 180.
How?
Sorry.
You add them with the given angle.
So you say what?
It's
114.
Yo, whoa, what happened? So you say 43.1 plus 65.8 degrees. What do you get?
60. No, it's 108.
108.4 degrees. And then you come here, you say 43 again. You say 43 degrees, comma 1 plus 114.2 degrees. What do you get?
157.3.
Ooh, we're having a problem now. 157.
Yeah, that's a big one.
Yeah, that's how I got my answers, and I thought.
0.3. Do you see that?
Mm.
La la. So we're having a problem. So meaning that B can either be 108 and B can either be what? 157.
157.
Are we all together? Guys?
Are we saying?
Yes.
Are we saying it can either be 108 or 65?
Yes. You see how it's confusing. You see how it's confusing you now.
Yes, they don't call them ambiguous for a reason.
Thank you. Thank you. They call it an ambiguous case for a reason, because now you are confused. You don't even know what to do now. So meaning that since we have two answers, our triangle is in this case. Hey, I can't erase here. Let me see. Can I erase here? Yo, okay. I've destroyed the slides. So meaning that the B will be like this. Now, our triangle is now like this, where I have an A, I have a C, I have a B here. Now I have two B's like this. Okay, let me write dotted line. So I have two B's like this. Do you see that? Where one is an acute angle and one is an obtuse angle. Do you see that? Or one is, both of them can be, not really both of them can be obtuse, but one of them is one of them. Yes, of course, one of them will be an acute and one of them will be an obtuse. Do you see that? Meaning the side A, this is also A, and this is also A. And this is B, and this is C. And then they call that B can be, let's say this is B1, and this is B2. Are we all together?
So ma'am, B1 and B2, when you add them one, they add 180.
No, you're no longer adding them. It's forming another triangle. There will definitely be over one. B1 and B2. Remember, B1 and B2 will be 180 because they are complementary of the other. You see that? So what happened is now you have this one, this small. I don't know how to draw. Now you have this part. It's not a right angle, guys. So this is A, B1, C, and then it's a small B1, C, and then you have a small, what's this now? A. And then you have a small C here. And then you have another one like this now, this one. Right, where you have C, B1, right? And then here they called it an A, and this is B2. And this is small B2, and this is C. So meaning now you have two triangles. You see that? That's when they said you can have two triangles, no triangle, or one triangle. You have two triangles now. So one can ask, okay, ma'am, so when I have two triangles, what do I do? These two triangles, they mean that they have the same A. So in this case, our A is equals to what? 43,1 degrees. Ne? And also this one has A is equals to 43,1 degrees. So meaning that they have different C's. Are we all together? Right?
Yes, ma'am.
Yes.
So then let's call this B1, angle B1. B1. Let's call this angle B2. So what you go and say, okay, fine. For angle B1, it will mean it will form a triangle, a new triangle. Now, so for this triangle, it will be like this. So there'll be A, B1, and C1. Now this one will form a new triangle like this. A, B2, and C what? C2. Meaning that we know A, we know B1, and we know B2. Are we all together? Guys?
Yes, ma'am.
So this triangle will be called A. Let's call it A1, B1, C1. Let's call this A2, B2, and C2. Now, what is missing here? We know A, isn't it? What is A? A1 is equals to what?
43.1.
43.1. And then B1 is equals to what?
108.4.
Why is it 108? We were checking here. We were checking. Don't use this. This part we were checking if it can be. Wow. That's where the ambiguity comes.
65.8.
So it's 65.8 then.
Thank you. 65.8. Here A1, A2 is equals to 43.1. And then B2 is equals to 114, so C1 here will be equals to what?
It's going to be
71.1.
So which is 180 degrees minus 43.1 minus 65.8 degrees, which is equals to 71.1 degrees. Are we all together?
Yes,
ma'am. There's one thing I'm confused about. So if it's two triangles, why is your A the same for both triangles?
It's because then only B was moving, not A. Do you see B was here, or B can move and come here? Do you see that?
Yes.
And what happens? Do you see that once B moves, it divides C, but it doesn't, we don't know whether it divides it equally or it doesn't divide it equally. Are we all together? It divides
Yes,
C,
ma'am.
right? And since it divides C, what happened is, then if it divides C, the only thing that is remaining is A, which is not unchanged. Does it make sense?
Yes.
I'm still lost.
So that does it mean A is the reference point?
So basically, it means that A, not really, okay, how am I explaining it? You can't say A is a reference point though. Does it make sense? We are saying that B can either be 1, 1, 4, like this. Meaning that if this is like this, if this is the entire B, but the entire B, the B can open up and be 1, 1, 4, right? Or B can be a smaller triangle. It's two cases, guys. It's not one case. Does it make sense? Or maybe I'm not making senses.
So what we must remember is that A is just a constant number for both triangles.
Yes.
But B and C can be,
so A is constant for B, and C will change. Okay, so A will remain. The given angle will definitely remain, right? But then B will change based on whether you having two. Remember when you are checking here, you have 1 and you have 2. Do you see that? So if you have 1 and 2, it means that if you have both cases, it means that now your angle has formed another triangle now. So it means you have two cases. Do you see that? And how do you check your cases? You check your cases in such a way that you take A, add the first case, take B, add the second case. If both of them are less than 1/8, it means now you have two new triangles.
Yes.
Do you see that? So meaning that you have this triangle over here. Ne? You have that triangle over there. Are we together?
Yes.
And then you come back and have this triangle over here. Does it make sense now? Yes or no?
So for that A on triangle on the right is also going to be 43.1. So that's the constant value.
You see that when I draw these two triangles, look at this. What do they share, both of them? The black and the purple one. They share that A.
They share angle A.
Yes.
Oh.
So now meaning that one of them will be 71 okay. 1B will be 65.8 and the other one will be 114.2. And then you need to have, then you can find C. So now in this case, C2 will be what, guys?
C2 being, okay, how much would be? Check. It'll be 22.7.
Now, guys, by looking at the graph, it does make sense. Do you see that? It does make sense that one of them will be an obtuse angle. If you look at this angle, do you see it looks like an obtuse angle? Guys?
Yes.
And then look at the small one. It looks like a what? An acute angle.
Acute.
So it does make sense that one of the B's is the obtuse angle and one of the B's will be an acute angle. And if if the B is an if the B is an obtuse angle, in this case, where is it? It's this one. It means C will be smaller. Look at our C. It's like we did cut C. Look at our C. Our C is smaller. Do you see that?
Yes.
There we go. Because if we look at the bigger triangle, in this case, it looks like this is B1. I think my labeling in J, it's not good, but the mathematics is correct. Do you see that? So meaning that if this is an obtuse, of course, this one will be smaller. If this is an acute, and this will also be larger compared to this one. Are we all together, yes or no?
Yes.
Okay. And both of them will share the same side because the black angle, it's A, it's this one. The purple one, it's A, is also this one. Okay. It's this one. Do you see why they share the same side as well? Because opposite to A is that one and opposite to A is that one. All together, yes or no?
Yes.
Yes, ma'am.
Okay. No. I need to remove this. So we got, okay. So let's go. There we go. Do you see that? What did we get our B1 as? Our B1 was 65 point something, isn't it?
65 something, yes.
Yes, so we were right. Do you see that?
The
acute angle, which is here. And the 60 is 65 point something. It means this whole part here will be 71. And this will be 43. And then this one, you can see it's an acute angle. Let me choose a different color. It's an obtuse angle, which is B2, this part. So let's continue. Yes.
No, okay.
So we then
sorry, why I just being curious, I just want to understand it. Why what's the explanation of the sides being equal again? The sides being equal.
Okay, let me finish this part first and then I'll explain it. So here, remember, we are checking the supplementary part, ne? And then we found that the angles can be B1 or B2, right? Two angles, that's what we got. Yes, and then we formed two triangles. And then after that, we found that one of the C1s is 71.1 degrees. Okay. Oh, sorry, we didn't go and check the side, guys. But I'm sure after you guys finding 71 point, you can always find the side for C, isn't it?
Yeah, that's what I wanted to ask. Would it be unchanged if we find the sign for C since we have two triangles now?
Yes, side for C will differ. One will be longer, one will be shorter. And then we solved and we did get 22.7, and then we found side for C. You see, one is this one is shorter and this one is longer, 2.257, and this one is 250. There we go. Do you see what I was talking about?
Yes,
guys. So
yes,
I'm explaining that triangle. So that triangle is like this. You see that? It's like this. Ne? And since that triangle is like this, we say this is A, this is B, and this is C. We know this is small a, this is small b, and this is small c, right? Now,
yes,
since we the first case, remember, we only found 30 degrees, and then 150 was not working. So then we had one triangle. But in this case, we found two B's. Do you see that? Now, when you find two B's, what happened is, in that triangle, another triangle is formed. Guys, someone must mute. Another
Ma'am,
triangle is formed.
mic.
Do you see that? Another triangle is formed. And when it's formed, one will have an acute angle and one will be an obtuse one. Angle greater than 90. And in our obtuse, we got that it was 114 and our acute is 113. Now, how are these triangles formed? Okay, the first big triangle, it's the whole big triangle. Do you see that? This one.
Yes, ma'am.
So they all share this 43,1 is this one. The whole big triangle, you take it the way it is, forms this one. Right? Meaning that that's the C. This C is the whole from here to there. That's it, the way it is. You take it the way it is. Then now you go and take the small triangle, the other formed triangle, because there are two triangles. This one. Do you see that?
Yes, ma'am.
It also has an angle A, and that A is that small a because it's opposite to this side. So A is also A here. And this one is this one over here. So meaning your given information formed two triangles and didn't have a unique solution. Are we all together now?
Yes, ma'am.
Thank you.
Yes,
this one. So do this one, and then I just need 2 minutes. Then I come back, and then we discuss it. Try it.
Are we discussing it here or are we doing it on our own?
I think we do it on our own, and we discuss it when we're done.
Okay.
Guys, are you winning?
Yes, ma'am.
Okay.
Yes, ma'am. Winning.
Ma'am,
Yes.
I'm not winning. I don't know what I'm doing, but when I'm doing my arc sign, it gives me error.
Who else is it giving them error?
Me also,
Me too,
because
ma'am.
I might have rounded off the last digit because there's a repeating number which is 99 when we try calculating for the sign of B.
Read read the heading. Read the heading.
No solution. Oh, okay.
Oh no!
So let's go back. So it means there was no solution. Actually, you were supposed to see it from here. Let me show you something. Something. You're supposed to come here and say, okay, I calculated, and then you calculate, and then you calculate, and then get 1.1 points, 1.17. Can someone say something? Why? Why was I supposed to see here? No, not yeah. Why was I supposed to see that here I won't get a solution? Can someone say something, please?
It's above 1, man.
Thank you.
Yeah,
Thank
it's
you.
above 1.
The range for sign is between -1 and 1. So it's above 1. So therefore, there's no solution. Since the sine of an angle is never greater than 1, we conclude that no triangle satisfies the given condition in this problem. We are done with the slide,
So
but
this is
now,
case 1.
yes, this is this is still case 2, the ambiguous case. You see how it was confusing it. This then draws back to saying this is always true for case 1. They say case 1, whatever. But case 2, where you are given side and an angle, there are many two. Okay, so there may be 2 triangles. We saw that, right? That we found 2 triangles. Yes or no?
Yes, ma'am.
Someone didn't
Yes.
see. Thank you.
Yes, ma'am.
And then, or you find 1 triangle. We did find 1 triangle at some point. Or you find no solution, which is no triangle. Meaning that that last case can be this one over here. This, where is it? The ambiguous. Where are you ambiguous? So it can be this one, where you have no solution possible. Are we together in togetherness?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So meaning that I can give you 5 minutes to breathe, and then we come back for the second slide.
Thank you.
Sharp.
Thank you.
And whoever is feeling not to come to the second